Hello, my little mathematicians. We are going to do a little warm up before we focus on dividing mixed numbers. So I want us to review normal dividing of fractions, or fractions with whole numbers, and we'll throw in some adding with subtracting and multiplying mixed numbers. So go ahead and try all the ones that you can. Pause the video and then unpause it, and you can come back and check your answers with us. Okay, for the first one, number 1, whenever you're dividing, you always want to remember keep, change, flip. Keep, change, flips means I'm going to keep that first fraction the same. I'm going to change division to multiplication. And I'm going to flip this second fraction. So instead of being 2 over 3, it's now 3 over 2. And if you're kind of confused of why is this happening? Why are you doing this? In a way, we always have done this. We just do it without thinking. Let's say that you go 10 divided by 2. Okay, we know that that's 5, right? But essentially what we're doing is we're keeping this the same of 10 over 1, because let's make these fractions. 10 over 1 divided by 2 over 1 is still saying 10 divided by 2, right? Well, if I do my keep, change, flip, I'm going to keep this the same. I'm going to change division to multiplication, and I'm going to flip the second fraction. So 2 goes to the bottom and 1 goes to the top. When you multiply across, 10 times 1 is 10. 1 times 2 is 2. And now you have 10 divided by 2, and you get 5. So with these simple things, like we just kind of do it in our head and it works out nicely. But with fractions, we don't even realize that it's happening, and that's what we're doing. So we're going to still continue that same pattern, but with a little bit more complex ones than whole numbers. And so we still go keep the first fraction the same, change division to multiplication, and flip this second fraction. Once you have it set up like that, because we don't know how to divide fractions, we actually only know how to multiply them. Okay, it's now set up as a multiplication problem. I do what I've always done. Can I cross cancel? Yes. 3 can go into both 3 and 9. 9 divided by 3 is 3. 3 divided by 3 is 1. When you multiply across, 5 times 1 is 5. 3 times 2 is 6. Can I reduce that? No. Is it improper? No. So I'm good. I'm done. Okay, for my next one, I'm going to do the same thing. I'm going to go keep my first fraction the same. Change division to multiplication. Flip that second fraction. Look to see if anything can cross cancel. Well, I know that both 4 and 8 is divisible by 4. So let's go ahead and write what you're dividing by. It just helps simplify so that you don't make errors if you actually write what you're dividing by. 8 divided by 4 is 2. 4 divided by 4 is 1. And then look the other numbers across from each other. Can 5 and 5 cross cancel? Yes, 5 can go into both. And 5 divided by 5 is 1, and 5 divided by 5 is again 1. Then, when you go to multiply across, 1 times 2 is 2. 1 times 1 is 1. And then 2 over 1 reduces or simplifies to 2. Okay, this one is almost the same, except I need it to be a fraction, so I'm going to put 5 over 1. Now I have a fraction times a fraction. Now that I have that, I'm going to keep the first fraction the same. Change division to multiplication. Flip that second fraction to now be 8 over 5. Okay, do you see anything that can cross cancel? Yes, 5 can be reduced because 5 can go into both. 5 divided by 5 is 1, and this 5 divided by 5 is also 1. Then you multiply across. 1 times 8 is 8. 1 times 1 is 1, and 8 over 1 is simply 8. Okay, for our next one, same thing. I'm going to keep my first fraction the same. Change division to multiplication. Flip that second fraction, 8 over 5. Now for this one, my 8's can both cross cancel, and they become 1. And my 5's can both cross cancel, and they both become 1. Right? Because anything divided by itself is 1. And then when you go to multiply across, 1 times 1 is 1. This 1 times 1 is also 1. And 1 over 1 is 1. And you're like, really? Well, yeah, look, 5/8 divided by 5/8 is 1. Anything divided by itself is 1. Okay, last one for these guys. I'm going to keep the first fraction the same, change division to multiplication, and flip that second fraction. Do you see anything that can cross cancel? Yeah, 2 and 6 by what? 2. And what's 6 divided by 2? 3. And 2 divided by 2? 1. Can the others cross cancel? By what? And what is 7 divided by 7? It's 1. Then when you go to multiply across, what's 3 times 1? 3. And 1 times 1 is 1. 3 over 1 is 3. Okay, now I know I'm in the groove, and so I want to go keep, change, flip, but is this a division problem? It's already a multiplication problem. So when I go keep, change, flip, I'm changing it to a multiplication problem because we can't divide fractions. But this is already a multiplication problem. So I can skip that first step and just move on to cross canceling. So anything you see? The 5 and 10 can cross cancel. By what? 5. What is 10 divided by 5? 2. What's 5 divided by 5? 1. And then when you go to multiply across, what's 9 times 1? 9. What's 2 times 2? 4. Can I leave it like that? No, because that is improper. So you take the top and you divide it by the bottom. In and out. Inside the house, outside the house. How many times does 4 go into 9? Twice, because 2 times 4 is 8. When you subtract that, you get 1. So then you put your remainder of 1 over what you divided by. So 9 over 4 is the same thing as 2 and 1/4, because 4 goes into 9 2 times and it has a remainder of 1, and then you always put it over what you were dividing by. Okay, let's review adding and subtracting. Those are a little bit different. For adding and subtracting, I want to first of all get a common denominator. And when I'm getting a common denominator, that's the same thing as finding the LCM. What's the smallest thing that both 4 and 5 can multiply to become? Well, the smallest thing that they can multiply to become, in this instance, is 20. Okay, now how did you get 20? You did 5 times what to get 20? You did times 4. So do the same thing to the numerator. Because as long as you do the same thing to the top and bottom, you're essentially multiplying by 1, right? 4 over 4 is 1. So I'm really not changing this. 2 times 4 is 8. And the reason I'm saying it's not changing is because you essentially just multiplied by 1. Anything over itself is 1. And if I were to reduce 8/20, I would get 2/5. So let's do the same thing on here up top. 4 times what is 20? 5. So do the same thing to the numerator. 1 times 5 is also 5. The reason I did this is because now I have the same denominator of 20. So I'm going to keep the denominator the same. And then I add the two numerators. Sometimes I like to circle the numerators so they stand out. 5 and 8 make 13. Don't forget those whole numbers in front. 6 plus 2 is 8. Can 13/20ths reduce? No. Is it improper? No. So I'm done. And then always kind of double check. 6 and something plus 2 and something should make 8 and something. Because so many times people forget to add the whole numbers. So you just kind of want to double check to see if your answer makes sense. Okay, for our next one, let's go ahead and take a look. It says you want to get a common denominator again, right? So what can 4 and 5 become? Exactly what we did last time, the 20. Okay, what did you multiply the 5 by to get 20? 4. So do the same thing to the numerator. And 2 times 4 is 8. What did you do to the 4 to get 20? You multiplied by 5. So do the same thing here to the numerator. 1 times 5 is 5. And you're like, I think you made an error because this is the same exact problem as before. No, it's not. What's different? This is a plus sign. This is a minus sign. So this time I'm subtracting. Well, can you take 8 away from 5? No, you can't. You need to borrow from the whole number. Now, when I add 1, I'm going to add 1 as a fraction. And 1 is the same number over itself, right? And it can be any number I want. It can be 1 over 1, 2 over 2, 3 over 3, 10 over 10, 100 over 100, a billion over a billion. Since I can pick anything I want, why not pick this common denominator to make it easy on myself? Okay, so I'm going to put 20 over 20 because remember, when I add 1, it's the same number over itself. So pick whatever this denominator is so that now when I combine these two, the denominator stays the same, and 5 and 20 make 25. So now the new numerator is 25, and I can take 8 away from 25. If you need to, of course, you can always show scratch work off to the side. I strongly recommend that rather than doing it in your head, because then you might make some simple errors. So 15 minus 8 is 7. Bring down that 1. And then you have 25 minus 8 is 17. Keep the denominator of 20 the same. Don't forget your whole numbers. 5 minus 2 is 3. Can you reduce 17/20ths? No. So 3 and 17/20ths is my final answer. For our next one, now we're multiplying. When we multiply with mixed numbers, I want to change the mixed number to an improper fraction. You cannot just multiply the whole numbers in front. It will not work out, okay? So if you tried that, it would be 6 and something, right? Let's change them to improper and see if it comes anything close to that. Well, when you're changing a mixed number to an improper fraction, you keep the denominator the same. You multiply the denominator and the whole number. 4 times 2 is 8. Plus 1 is 9. Same thing here. Keep the denominator the same. 3 times 3 is 9. Plus 1 is 10. Now, I don't need to do keep, change, flip or anything because they're already multiplying, right? Okay. Now I look to see if anything can cross cancel. Yeah, 4 and 10 are both divisible by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. What about the other numbers across from each other? Do you see anything? Yeah, 3 can go into both. And 9 divided by 3 is 3. 3 divided by 3 is 1. When you multiply across, 3 times 5 is 15. 2 times 1 is 2. Can you leave it like that? No. So what you do is you take the top and divide it by the bottom. 2 goes into 15 7 times because 7 times 2 is 14. When you subtract that, you get a 1. So you put your remainder over what you divided by, which means 15 over 2 is the same thing as 7.5 because 2 goes into 15 7 times and has a remainder of 1. Okay, our last one. We technically haven't done this before, but it kind of is similar to multiplying. So let's first change our mixed numbers to impropers. I'm going to keep this as 4. Then 4 times 3 is 12. 12 plus 3 is 15. Divided by, this stays a 2. 12 times 2 is 24. 24 plus 1 is 25. But remember, whenever we're dividing with fractions, I want to change it to a multiplication problem. So I'm going to keep 15 over 4 as 15 over 4. I'm going to change division to multiplication. And then I'm going to flip that second fraction. Whatever was on the top goes to the bottom. Whatever was on the bottom goes to the top. Okay, and now that you have a multiplication problem, let's just go ahead and simplify it. What can go into both 15 and 25? 5 can. What is 25 divided by 5? It's 5. And what's 15 divided by 5? 3. What can go into both 2 and 4? 2 can. What's 4 divided by 2? 2. What's 2 divided by 2? 1. Then multiply across. 3 times 1 is 3. 2 times 5 is 10. Can you reduce it? No. Is it improper? No. So I'm done. Okay. Congratulations, my little mathematicians. You now know how to add and subtract mixed numbers with borrowing and multiply and divide mixed numbers. You're on your way to mastering everything there is to know about fractions. Good job.